Hello, and welcome to the Virtual College Exploration for all North Carolina and South Carolina students, sponsored by the Carolinas Association of College Registrars and Admissions Officers, and StriveScan. Thank you for joining us today. A few housekeeping announcements before we get started with the panel presentation. You can use the Q&A button on your screen to type in your questions to our presenters at any time during this presentation. Your camera and microphone are off, so the panelists cannot see or hear you. This is just one of many sessions happening, so be sure to check out the full schedule at CACRAO.org, which is CACRAO.org. And then also this presentation is being recorded and will be available within about a week at the same website at CACRAO.org. And now I'll turn it over to our presenters.
And I will share my screen. Did I share the wrong screen? I think I did. Sorry. This screen. We good? Okay, awesome. Good afternoon, everyone. Welcome to today's session. We're excited to be with you to talk a lot more about the field of engineering specifically. Before we dive in, I'm just going to invite all the panelists to do a brief introduction, who we are, what school we work for, and a little bit about our school. So we'll start with Nakia.
Good afternoon, everyone. My name is Nakia Bradford. I serve as the Senior Assistant Director of Freshman Admissions here at North Carolina A&T State University. We are the nation's #1 public HBCU, and we are the #1 producer of African Americans attaining their degrees in engineering, and we are located in Greensboro, North Carolina.
Hello, everyone. I am Ronnie Chalmers. I represent North Carolina State University. We are the largest school in North Carolina. We have about 19 different engineering programs, and really happy to be here today.
Good afternoon, everyone. My name is Russell Moore. I'm a regional recruiter for the University of Alabama. I'm based in Jacksonville, Florida, but I work a lot with students in the South Carolina Lowcountry. University of Alabama is located in Tuscaloosa, about 1 hour west of Birmingham, and we have almost 38,000 students, but almost 60% of them come from out of state.
Awesome, and I am Chelsea Whitman, Assistant Director in Undergraduate Admissions at UNC Charlotte, where we are the 3rd largest public university in North Carolina, with a College of Engineering devoted to rigorous curriculum and hands-on opportunities that our students take full advantage of in the greater Charlotte area. All right, so in terms of today's session, this is essentially how we've broken it down. So we will be discussing several disciplines within the field of engineering to kind of highlight similarities and differences across the different fields that you can pursue as an aspiring engineer, talk about employment areas, career data, things like that across the board. In today's session, we're also going to talk about or highlight opportunities that engineering students typically take advantage of when they're not in the classroom, so both professionally and socially. And then we will certainly save time at the end to cover important steps that you all can be doing to prepare for a major in engineering for the future. So if you are a student who enjoys participating in experiential, hands-on projects, and you love to visualize, design, create, and build, you're certainly in the right place for today's session. So I think it's safe to assume that the majority of you in the room this afternoon are either planning to apply within a program of engineering, or you have interest in just simply learning more about engineering to determine if it's a good fit for you. And so that's why we're here. Really just to talk about these are the specific areas we'll be highlighting in terms of some of the various disciplines that you have opportunity to study in at our various schools. A lot of the disciplines we'll be covering today are areas you're likely already familiar with, and then we'll certainly be highlighting maybe some areas within engineering that you're not as familiar with, just to kind of give you a very big picture outline of the field of engineering. So we're going to start today's session with covering architectural engineering, and I'm going to pass it over to Nakia.
All righty, thank you, Chelsea. So of course, within the discipline of architectural engineering, these individuals will specialize in the design, construction, and maintenance of buildings. They will also create structural systems such as heating and air conditions, as well as fire protection systems. These individuals will have the opportunity to collaborate with other engineers, architects, project and construction managers, and architects to design, construct buildings and building systems. So one thing we wanted to make clear today is the difference between an architectural engineer versus an architect. So an architect will focus on the design of a building's look and style. Architecture is more so a design major, and it's not focusing on the nuts and bolts of the grand scheme, rather just the look. Architectural engineers will ensure that the design is sturdy and functional for individuals who will occupy the building. Before the 21st century, one person will usually handle both jobs, but within the 21st century, they become separate specialties. Architectural engineers will focus on, of course, the structure of the actual building, systems that will hold this actual structure, solve load analysis. They will budget the actual project, building forensics, sustainability. They will have to be aware of what is causing the change in an environment and how does that affect the buildings and structures and whatnot. How to limit waste within the construction site, as well as indoor quality. So some quick facts about architectural engineering. The median pay is about $119,000. To enter the field, they're typically looking for a bachelor's degree, and the employment is projected to grow within the next 10 years, about 6%. All right, the next discipline we're going to cover today is biomedical bioengineering. So pretty much these individuals will apply engineering practices in general biology. More specialized bioengineering will utilize engineering in disciplines to improve human health. So pretty much bioengineering is the application that will solve problems within medicine and healthcare, and it's actually bridging the gap between engineering and medicine. Bioengineers are responsible for innovations such as prosthetics that restore limb function, implanted simulators that restore heart function, and biomaterials for tissue regeneration. Some quick facts about biomedical engineering would include the median base pay is about $91,000. The bachelor's degree is typical for entry level. However, master's degrees and additional job experience will give you a greater chance of a higher paying job. These higher paying jobs would include areas such as, within research and development, pharmaceuticals, and medical equipment manufacturing. So here in Aggieland, our students are conducting research within architectural engineering, and it will cover construction materials, energy and building science, renewable energy, environment modeling, and water resources. And within Aggieland, our students within biomedical engineering are studying diffusional studies, polymer processing, process control, and catalyst research. So thank you so much for your time, and I'm going to pass this along to my colleague.
All right, thank you so much, Nakia. So I'm going to talk to you a little bit about aerospace engineering. And this particular field is pretty popular with students. You know, everyone wants to either learn how to design a plane, fly a plane, or be an astronaut. We actually did have a recent astronaut in space, so we're really excited about that. But aerospace engineers primarily design aircraft, spacecraft, satellites, and missiles. They also create and test prototypes to make sure they function according to design. And some of the career paths you see here, commercial aerospace engineer, spacecraft designer, inspection and compliance, something that people don't always think about. data processing managers, another area, aerospace technician, and then also aircraft drafter. In terms of some research opportunities, we're looking at aerodynamics, fluid mechanics, propulsion, and space exploration. And here in the picture, you have one of our students who got into our wind tunnel. It didn't go so well. Just joking, that's not one of our students, but that'll give you an idea of really what happens in a wind tunnel. It is very, very hands-on, and that's an opportunity for students to test aircraft designs, for passenger aircraft, also drones at supersonic and also subsonic speeds. In terms of employer, GE Aircraft, Lockheed Martin, Honda Jet, Boeing, SpaceX, and there's so many more that are hiring students in this particular area. And also career data in this particular field, 116,500 is mean annual salary, and also it's projected to grow at about 3%, which is right at the average over the next 10 years. The next field I want to cover is a field that a lot of students don't know about, but it's really awesome. And one thing that makes it very unique is that the abundance of scholarships. The companies in the industry, they're looking for textile engineers, but not many students know about it. So I really want to highlight that today, that many students can come into that particular field, not pay much or sometimes not pay anything for their education, and then come out of school with no debt. And it is a joint interdisciplinary program with textiles and engineering. And basically textile engineering is the application of scientific and engineering principles to design and control all aspects of fiber, textile, apparel, processes, products, and machinery. Some of the concentrations in this area would be chemical processing, information systems, and product engineering. In terms of products that are used, they are used across a wide range of fields. So you're looking at aerospace, medical, transportation, fashion and textiles, military, and packaging. And one thing that you'll find in textile engineering, a lot of research and technology behind thermal protection. So many schools will have a thermal protection lab. At our school, it's called Pyroman. And it basically is full-scale testing of garment systems to make sure that they are flame retardant. So you're going to think about fireman suits, making sure that our firemen are safe. Also, the silver blankets that you find if a fireman is out fighting a forest fire and maybe the fire moves more quickly than expected, they may be surrounded and they can get under that blanket and hopefully increases their chance of surviving. Also, just thinking about how it goes outside of the traditional thought of textile engineering, astronaut suits. That's going to be many of those fibers that are created are going to be from textile engineering, race car uniforms, also synthetic skin. So most things that you're going to find in a hospital, inside or outside the body, depending on the procedure, that's going to be a textile engineer that's going to create those fibers or fabrics. And then finally, looking at some of the career data, 94% career placement and success rate. So like I said, there are plenty of jobs opening, about $63,750 in terms of salary, but also expected job growth is through the roof right now. And especially looking at COVID and what it's done to the medical industry. Well, a lot of the different fabrics, fibers, plastics, things like that, those are also going to be textile engineers. So that might be a part of why that job growth is going to increase, because for the foreseeable future, we're going to need additional fabrics, fibers, and things to help fight COVID for sure.
All right. Thank you, Ronnie. Chemical engineering, when I meet with students at college fairs and talk with them in these chats, students are typically mentioning several different engineering fields, but rarely do they mention chemical engineering. So I'm glad that we were able to have this presentation to talk more about this particular field of study. The first thing that a lot of people think about if they're thinking about chemical engineering is working in the oil and petroleum industry. But And we do have a lot of people in this country who work in those areas, particularly along the Gulf Coast. But there is so much more that chemical engineers can do, and they have a great impact on your life day to day. So many products that you use and the ease of their use is made possible by chemical engineers. You see some of the career paths mentioned here, the food that we working in food production and processing facilities, or perhaps having a hand in the development of pesticides and herbicides that make farming more productive, plastics that you use every day for a variety of different containers and applications, even on the clothing that you wear. So there are a lot of different things that chemical engineers are involved in that have a huge impact on your life. But pharmaceutical industry is one of the biggest sectors in the U.S. economy, and chemists and chemical engineers have a great hand in that as well. In terms of some real life examples of people who I know, I, for example, have a coworker whose brother works in oil and gas exploration in the Gulf of Mexico, and he spends a significant time in oil rigs and working day and night to try to improve and maximize the return on oil and gas, and look for those spots for drilling. I also know someone. I'm based in Jacksonville, Florida, working for the university. I know somebody who works for Johnson & Johnson, which makes a number of different products that we use, such as contact lenses, and she helps with developing chemicals that make for smoother surface materials for items like contact lenses. So that's another good way that a chemical engineer has perhaps made your life a little bit easier, so you don't have to wear glasses. And then also, I worked with a student who graduated a few years ago from the university who studied chemical engineering. But while he was an undergraduate student, he was able to get paid as a tutor, and he would help tutor student athletes who were taking chemistry courses. After that, he was deciding whether or not to go to graduate school. A lot of people in chemical engineering go on to get a master's or a PhD. That is much more typical in that profession. And he decided, at the recommendation of a few people in different walks of life in chemical engineering, to go and get a master's degree in business. And that knowledge of business principles and being able to understand budgets and finances, especially if you are a self-employed consultant or become a partner in a major firm, that's becoming more and more important. Next, I'd like to talk a little bit about environmental engineering. After the creation of the EPA, the Environmental Protection Agency, and you had more regulation for protection of the environment and wildlife, starting in the 1970s and 1980s, you saw tremendous growth opportunities for environmental engineering and more environmental engineers hired. Mean annual salary, as you can see, is very good, and career growth prospects are solid for environmental engineering, particularly as we keep developing and as cities keep growing. And you do see, particularly on the east and west coast of the US, where we have our largest concentration of population, that's where we will need more environmental engineers in the future. You do see, especially with water and water quality, you see a lot of environmental engineers employed in those areas, and they are consultants. Where they may have impacted you most in your daily life is the house where you live, or the grocery store that you go to shop for food. Anywhere that you've used a road or a building, chances are there were one or more environmental engineers who were consulted to make sure that what was being built on that hillside or what was being built in that previously undeveloped area was going to that the impacts of that development was going to be minimal on the surrounding area, and also to ensure your health and safety, to make sure, for example, that if a road's built on a hillside, that they're going to decrease the likelihood of having difficulty of poor water runoff or of a landslide of a developed area. In terms of real life examples, in the neighborhood that I lived in, there was someone in our community who had a problem with water that was pooling in his yard. The landscape had changed over several years since that area had been developed because of excessive rainfall. And we had an environmental engineer who worked with the Homeowners Association to consult on how to drain that water away from his home so he could sort of reclaim his yard. And another example, someone who I knew personally, is my cousin, who became an environmental engineer. He had a cooperative education assignment, which we'll talk about a little bit more later, at General Electric, at GE. And from there, he went on also to get a master's degree in business. And now he's a consultant for a large engineering firm. He supervises a team of engineers that assist utilities companies on energy consumption and efficient operations.
Thanks, Russell. All right, so next up, we're going to talk about civil engineering, looking at the fact that civil engineers work with some of our planet's most basic building blocks. Think about wood, earth, water, sunlight, and stone. But they also work to solve some of our planet's most serious problems, such as environmental pollution, aging infrastructure, need for an alternative energy source, and overcrowded transportation systems, just to name a few examples. But as planners, they essentially envision the future, especially how and where we will live and how we will travel. So civil engineers design and supervise construction of bridges, buildings, roads, and other structures. And they may focus in specific areas like transportation, environmental, structures, or geotechnical. So if you like safe drinking water, a clean environment, and efficient transportation, you want to thank that civil engineer that you may know or have in your life in terms of areas that they specialize in. You'll see here a list of primary employment areas for civil engineers, and then just taking a glance at the career data, you'll see that the average annual salary for a civil engineer is a little over $87,000, with the projected growth for employment opportunities being about 2% over the next 9 to 10 years. And mechanical engineering. So this is an area that you are all very likely familiar with, but essentially mechanical engineers impact all technology of the past, present, and future, from the early manufacturing of Model Ts to the launching of today's space shuttle, to the development of tomorrow's alternative energy sources. Mechanical engineering is integrally involved. So mechanical engineers design machinery and personal products with movable parts. So this includes everything from automobiles to robots to air conditioning systems for buildings. It's a broad field that also branches into fields such as medicine and nanotechnology. So you'll see examples here of popular employment areas for mechanical engineers, and see that the average annual salary for a mechanical engineer starting out is about $88,000, and the projection for employment growth is sitting at about 4%, which is along the lines of the national average over the next 10 years. And then the last discipline we're going to highlight in today's session is systems engineering. So systems engineers work to integrate essentially engineering and business operations. So they are integrating these to incorporate both fields in design, production, manufacturing, logistics, sales, and revenue. So system engineers create and execute processes to ensure that organizations can meet customer and stakeholder needs in not only a cost-effective manner, but also a safe and timely manner. So they develop efficient ways to accomplish goals in various industries, essentially. And here you'll see some different fields or jobs within systems engineering, looking at being a systems engineer, a manufacturing engineer, a power systems engineer, industrial engineer, and so forth. The career data here that I've highlighted is really looking specifically at an industrial engineer. So the average annual salary starting out is a little over $88,000, and the projected growth for employment opportunities over the next 9 to 10 years is 10%. So greater than the national average there. All right, now we're going to shift gears a bit and highlight some of the areas that students in engineering find themselves, what they're doing when they're not in the classroom, kind of looking first at the professional opportunities that they take advantage of, and then we'll talk a little bit about the social opportunities that that engineering students take advantage of. So I'll pass it over to Russell.
Thanks, Chelsea. Many of you, or all of you, have probably heard of internships. Some of you may have had an internship during a summer or during a 2-week break, perhaps working at the office of a friend of a family or something like that. But some of you may have not heard of cooperative education, which is typically called co-op. And universities that have engineering programs will often have 1 or 2 staff members or an entire office dedicated to co-op placement and facilitating interviews between students and company human resource departments. The biggest difference, and some people use the term interchangeably, but you really shouldn't. The biggest difference between the two is that if you're doing co-op, you're employed full-time and you have much greater responsibilities. Colleges of engineering and engineering majors, they're going to typically serve in co-ops versus internships that you might see in communications related majors, for example. And in this setup, you'll normally alternate between the workplace and your campus. In some cases, students may be 2 or 3 hours away from campus, living in an apartment adjacent or near the company where they're serving in that co-op, and spend an entire semester or quarter at the job site, working on whatever project or projects they have you doing, learning under people who can serve as your mentors. And then you go back to school, get another semester of coursework and lab experience under your belt. And with that additional knowledge, you can then go back to your co-op and learn additional things. Because it's engineering, and because of the highly specialized nature of what someone is doing typically in an engineering co-op, pay is much better than what you'll find in typical internships in many other fields of study. That pay can vary. Sometimes it can even go up above $18 an hour, sometimes as high as $25 or $26 an hour. And even though it's not required at all university engineering programs, it's highly recommended. And the National Association of College Employers found in 2019, for example, that 50% of the co-op participants were offered a position by their previous employer once they graduated. And at some universities, 70 to 80% of their co-op participants were employed by that same company. So it's something that you should really, really consider doing. At the University of Alabama, for example, we've had students who have co-opted at Mercedes-Benz, NASA, Northrop Grumman, Alabama Power, and Georgia Pacific, just to name a few of them. Additionally, I'd like you all to think about opportunities for undergraduate research, which oftentimes begin as early as the sophomore year in engineering. It can take a lot of different forms. You could end up doing data analysis or product testing, or even helping with the construction and design of something that's going to be patented. We've had some students who, working along with professors, even earned a writing credit in a published academic journal. Having that research allows you to learn so much more outside of the classroom and build a much closer relationship with professors who could have a tremendous impact on your life. They might provide a wonderful recommendation letter for you to go to graduate school, or they could really help you in this research project in taking your career in a totally different path that you hadn't seen before, that opens up a lot of doors. So in your freshman year, talk to engineering professors and speak with them about what they're involved in research-wise, and explore what those options are and find out how soon you can get involved in.
Awesome. And then looking at kind of shifting over to the social aspects of how students get involved typically outside of the classroom. So this is just to highlight some traditional areas that you might find. There might be called different things at different campuses, but it's very common to see learning communities within the College of Engineering at schools that you're looking at. So it could be called something different, like I said, but essentially the concept of the learning community is to provide a residential learning space where all engineering students have the option to reside on the same hall, in the same building, if it's devoted specifically to the learning community. At UNC Charlotte, our learning community is specific to one full building. And those students, outside of living together, they also have on-site classes that are in the building and tutoring, and then they do out-of-class learning opportunities together as well. Then there are things like, or programs like Engage Me, and this is specifically a College of Engineering, multicultural engineering program. So it focuses specifically on underrepresented students in the field of engineering. And so that also might be something that is called various things at different schools, but something very common that you'll find across the board. You also have things like Leadership Academy. It's going to have a little bit more of a focus placed on some professional opportunities, but it's still an extracurricular in terms of something you take advantage of outside of class time. But the Leadership Academy for us is something devoted to upperclassmen within the field of engineering. And it's essentially there to develop leadership training based on corporate modules. So it really helps them to prepare, since they're about to embark on the interview process and starting out as an engineer pretty quickly beyond those last 2 years of the program. Then you also have opportunities in student organizations. So at UNC Charlotte, there are 25 student orgs devoted to interests of engineering students. So that's something you will find across most campuses, that there will be so many clubs and organizations in general, but you'll oftentimes find a subgroup of orgs that are devoted to the interest that align with engineering students specifically. So just some examples of engineering professional societies. You've got the American Society of Civil Engineers, the National Society of Black Engineers, the Society of Women Engineers, and the American Society of Manufacturing Engineers. So there's a lot out there that students take advantage of in terms of opportunities to kind of round out their full experience. All right, and then last, we've saved a little bit of time to cover things that you can be doing now as a student to prepare to major in engineering.
All righty. Thank you, Chelsea. So while you're in high school, in order to prepare for engineering, one of the things you want to make sure is that you're taking rigorous math and science courses, right? Because in college, engineering majors will take these advanced courses, these rigorous courses that are packed with math and science. So you want to prepare yourself by taking the most challenging math and science courses. These may include AP Calculus, AP Physics, AP Chemistry, AP Computer Science, and Statistics. If your school does not offer any AP courses, please feel free to take the highest level math available at your school in order to prepare for these rigorous courses here in college. You want to be sure that you're also joining clubs and organizations that are associated with engineering. This is one of the ways that you're able to demonstrate your passion for STEM, and it's relevant to your college journey because it's an extracurricular activity that will pertain to your future degree and your future job. So clubs that you can join to fulfill this passion would include engineering club, math club, physics club, robotics, chemistry club, and coding club. And you may want to start tutoring other students within the math and science classes to reinforce what you've learned, and also to reinforce your resume. You also want to speak with engineers about their career and ask for their advice. We understand that you will be able to gain experience, gain additional information about your field through coursework and extracurricular activities, but it definitely helps for you to have that experience and that real life application. You can build real world engineering experience through job shadowing, internships, or volunteering. Real world experience builds skills and knowledge and gives you another opportunity to evaluate whether engineering is a career for you. Of course, all of these experiences will look great on your resume, and I also would like to expand on that. While you're speaking with these professionals, you want to also ask those difficult questions such as, what do you not like about your job? Just so that you can see if you really can see yourself doing this job and these functions on a day-to-day basis. So you definitely want to ask those tough and challenging questions.
All right, thank you, Nakia. So one thing that Nakia highlighted was how to, build your resume, how to present things that are going to be really helpful in your application process. So one thing is attending a summer engineering camp at a university. It doesn't have to be the university that's your number one choice. When reviewing applications, we like to see that you're taking advantage of experiences outside the classroom. So that's something to really think about, looking at the different opportunities that are out there. Each of our universities have plenty of summer opportunities, engineering, in STEM in general, or just different types of summer programs. So we want you to get involved outside the classroom. Also tour several campuses. Right now it's a little bit challenging because of COVID-19, but many colleges, in response, we have our general info sessions that we're doing virtually, but also now you can get into a specific engineering session. So you can start thinking about, what's going to be the best experience for me, who's going to be my best fit. Also looking at speaking with university admissions and engineering staff. So it's good to talk to both just to get an understanding, find out if there's an additional application. Do certain programs require a portfolio. So all of these things are going to be very important in your process. And I know we only have a couple more minutes, so we want to get to our Q&A as quickly as possible.
Yes, so you all have sent great questions. I think we've been able to address some of the questions throughout the presentation, but I'll go ahead and pitch the first one your way, Ronnie. So will textile engineering help me with becoming a product designer and a fashion designer / make my own clothing line?
Yes. So if you're looking more at fashion, I would say our fashion textile design program or a fashion program at another school would be probably best. Our program is different at NC State in that it does have a science and math component. So yes, we're teaching students how to design clothing and what's going to really look awesome, but also functionally, how does that work? And also, can you make it sweat wicking? Can you charge your cell phone through putting in different solar panels within the clothing as well? So thinking about the science of it is really what we're focused on in that particular field, but we do offer a separate fashion textile design that isn't necessarily engineering.
Awesome, thank you. Next question, this is a great one that came in early that I think will get us to talk a little bit about something that likely many of you are curious about. So I'll just throw this out to the group. But when do you have to declare that you want to go into engineering? Can you change your mind once you are at the college? Does anyone want to?
So here at A&T, you do have the opportunity to choose 2 majors on your application. So should you not get accepted to your first major of choice, you can have the opportunity to shoot for your second. But definitely, oh, I'm kind of lost my train of thought. What was the question again? I started reading another one.
about when do you have to decide if you want
Yes.
engineering and can you change your mind?
Yes. So here at A&T, we encourage you to go ahead and research and know what you may want to major in, simply because we try to get our students to graduate within those 4 years, especially as engineering is a rigorous major, and it's a lot to do, especially there may be internships, co-ops, opportunities that you may want to take advantage of. So we do try to get you in as a freshman as soon as possible if you are interested in engineering, and it's difficult to transfer into because of the prerequisites and whatnot. So here at A&T, we do encourage you, if you are in fact interested in engineering, please let us know so we can try to get you in, but we definitely encourage you to know ahead of time, as you have required internships, co-ops, things of that nature, and it has a heavy timeline, if you will.
And something I will, and I know Russ, I'll let you also add, but just to elaborate, we got another question about struggling to decide between computer engineering and computer science. So to fold that into this, I will just say we have the option that you can actually apply to engineering undeclared in a discipline. So if you're not sure of the specific discipline, you can apply what's called engineering undeclared, and then you're being evaluated for the College of Engineering to begin those intro into engineering courses without having to necessarily decide which discipline right out of the gate. So that's an option. Russell, did you?
That's what I was going to say as well, Chelsea. We offer that option. And the University of Alabama does not have any separate application required for a student to enter any of the engineering majors. But if you are going to change this and declare engineering, the sooner you do it, the better, because of the significant number of math and science courses.
Awesome. Next question, I think I'll throw it out to the group. Something we didn't talk about, but might be worth mentioning. What's the recommended GPA for entering this field? And what type of scholarships can we get to help us for this field? Ronnie, I'll throw it to you.
I didn't hear the actual field.
So what is the recommended GPA for entering this field? I think just engineering, and then types of scholarships.
Oh, awesome. Well, I wouldn't say that there is a recommended GPA. I think that, making sure that you have a strong background, as we've talked about in the math and science field, trying to take the highest level math at your high school. Every school is going to be different in terms of, how many students are applying for that particular major or that particular institution. In terms of scholarships, I encourage you to start your search early, but many institutions, because of the general engineering program in that first year, sometimes scholarships for engineering, and this is not all schools, scholarships for engineering start really that second year when you get specifically into your area. And that's where you'll find more of that. But one thing that is very unique about engineering, and we've talked about, is the co-op program. So even if you're not getting a scholarship, well, if you during your co-op program can make $30,000 or $40,000 through co-op, or $15,000, well, that's going to help you pay for college as well. So there are other ways, even outside of scholarships, to help you pay for that, or even research opportunities. You can get paid for that also.
Great. And then just to follow up on the co-op, so do students that do a co-op typically take longer than 4 years to graduate?
Yes, that will be the case. But it is well worth it to delay that time of graduation because of the work experience you gain and the increased opportunity to be employed by the company that hired you to do co-op. My cousin, he did a 4-year. The program would have taken him 4 years. Many students take 4.5 years in engineering at our university, but co-op may make it 5 years. But again, the benefits that you get along the way far outweigh the graduation time.
Awesome. And then I think we've got time hopefully for 1 or 2 more questions, but we've gotten a few tied to test scores, so I'm going to fold these in together. What is the recommended test score like SAT or ACT? Does someone that does have their ACT have a greater chance of acceptance than someone who has not taken it?
So I'll jump in here, at least for the UNC system schools, hopefully I'm speaking for everyone, we are test optional also for engineering. So there's not gonna be necessarily, like if you don't have a test score, it's not gonna hurt you in the review process. I think right now focusing in on, and this is just for students who are applying for 2021, you know, focusing in on how well you're doing in your courses, especially ones critical to the academic program.
I just wanted to hop in on that as well. As we are test optional within the UNC system, here at A&T, we do have a departmental requirement. So we're looking for our students to meet a weighted GPA of a 3.2, and you must have satisfied pre-calculus or calculus. If you did not satisfy pre-calculus or calculus, the Department of Engineering will then look for your test scores. So if you're looking into engineering, we're looking for an overall SAT of a 1080, 520 math minimum. If you do take the ACT, we're looking for a 21 composite, 21 math minimum.
Awesome. And it looks like we are at time. So sorry we're not able to get to all questions, but thank you all for joining us. We hope that you took away valuable information regarding engineering. And this slide provides follow-up information for each of our individual schools. Should you have questions and want to reach out to us, we would love to hear from you. Thank you all for your time. I think I'll pass it back over to CACRAO. I think, perfect.
Yes. Thank you for joining us today. After you close out your window, you will receive a quick 4-question survey. So if you could just fill that out, we would appreciate any kind of feedback that you could provide. And you can also sign up for more sessions at the CACRAO.org website. And then also this recording will be available within about a week if you would like to review it later. Thank you for joining us today.